Okay, this is the last section in chapter 12. We are looking at scatter plots, correlation, and regression lines. So we are going to make scatter plots, interpret data from a scatter plot, and use technology to find the correlation coefficient in the equation of the regression line. So I'm going to use the 84. You can use 83 or anything higher than that. So whenever you plot points, just a reminder of how to plot points. The first number is x, the second number is y. And so if we're plotting points or writing the points, let's talk about quadrants first. This is my first quadrant, and this is positive, positive. So every value inside this square is a positive, positive. This is quadrant 2, which this would be, x would be negative, y values would be positive. So 1, 2, and then 3. So it'd be a negative, negative. So negative x value and negative y value. And then 4. This is positive, negative. So positive x value and negative y value. So those are your quadrants. It goes in the opposite order, counterclockwise. There we go. I was trying to think of the word. All right, so let's look at these values for each of these points. So A is right here, which is -2, +1. So you look at how far left and right, and then the y value is the up and down. So A is -2, 1. B is 3, 4. C, 1, -3. D, -4, -2. E, 0, 3. And then F, I did not put F there, but F is at 4, 0. So you can plot points on a coordinate grid, and anytime you have a collection of points, it's called a scatter plot. And you can actually collect real data and plot it on a scatter plot. You would have to have something that represents X, which is like an independent variable, and something that represents Y, like a dependent variable. Like age is independent, um, blood pressure. That's the examples we have on this. Could be Y values. So you can collect data on that. And to determine whether two quantities are related. So correlation, a clear relationship between two quantities, used to determine if there's a relationship between two variables, and if so, the strength and direction. So you can have positive and negative correlation. You can have a strength that shows strong or a very weak correlation. So here's a plot, kind of plot. So these are all going in an upward direction. You always want to read them from left to right. So this is a positive correlation. There's a clear relationship. The quantities are said to be correlated if there's a clear relationship. The scatter plot shows an upward trend among the data points, although there are a few exceptions. People with increased age tend to have higher blood pressure. Correlation is not necessarily causation. So they're not necessarily like a cause and effect relationship. So I can't say because you're getting older, your blood pressure is going to go up. There might be some other underlying conditions that have to be proven to show that one causes the other. So we can't say causation. We can say they're correlated though. Regression line, it is like a line of best fit. So if I were to draw a line of best fit, it would kind of fit within the middle of all of the data values. Something like that. We can actually get our calculator to give that data to us, that information. So a line of best fit will be a linear relationship, y equals mx plus b. So the only time you can do regression is if there's a linear relationship going on. Correlation coefficient is going to be identified by the letter R, It's a measure that's used to describe the strength and direction of a relationship between variables whose points lie on or near a line. So positive looks like it's going up, it's an upward trend. So that would be considered positive. You have your x and y axis here. And then negative would be, of course, if it's going downhill. Okay, that's negative. Perfect positive is in which all the points lie precisely on the regression line that rises from left to right. Perfect negative, all the points lie on a negative line. So perfect negative would be in a straight line. Perfect positive would be in a straight line. Those have a correlation of exactly 1 for the positive one and exactly -1 for the negative correlation. So this kind of tells us what our values are going to be. They're going to be between -1 and +1. So if you have this number line where you have 0 in the middle, +1 here, -1 here, anything close to +1 or -1 is considered strong. Anything close to 0 is considered weak. If it's on the negative side, it's a negative correlation, meaning it's going a downward trend. If it's on the positive side, it's more of an upward trend. So like I said, our calculator can find the R value for us. Here is what different scatter plots look like according to R value. So that's perfect positive. 0.8 is still positive. It's just not in exactly a straight line. 0.3, it's still positive, but it's really spread out. And then 0 is no correlation. Then we go negative 0.3, downward trend, but not in a straight line. This is more of in a line, but it's at negative 0.8 going downhill. And then this is a perfect negative correlation. So we can answer questions on a scatter plot. So you could make your line of best fit going through here. It says approximately how many births are there with approximately 45% females of childbearing age using contraceptives in Vietnam. So we're using the line of best fit or regression line. So it says 45%. So we're going to look here, percentage of married females using contraceptives. So 45 would be right here. We're going to follow it up till we get to the line. So looks like it's about 4. Okay. Annual per capita income in dollars and then percent happy. So it says interpret data from a given scatter plot. Is 0.2 a reasonable estimate? Well, if we have a line here, say 0.3 would be like this. This looks like it's more in a line, so I would say no. 0.99, is that a reasonable estimate? I would say no, same there, because it's not a line. And then this one's a no because it's not scattered out enough. But you know what I would say is a pretty good estimate? I would say like 0.8, 0.75. I put 0.75. We know it's not 0.99 because that's too much in a line, and this is not in a line. It's more spread out. Okay, so let me show you the formula for a correlation coefficient. That looks like a lot of fun, right? So we could do this by hand, but we don't have to because we are going to use the calculator. Here is what all these symbols mean. So we know the summation, we know x and y. N is how many values there are. So this tells you sum of all y, x values, sum of all y, product, some squares. It's a lot. So I'm going to teach you how to use the calculator. Okay. So first thing you have to do is go to mode and do stat diagnostics on. Let me show you how to do that. So stat, edit. Let me go do it. Oh, I need to go mode first. Mode, go down. I'm going to put it on. And then I'm going to go to my next step. Once I have that on, if I don't turn that on, it won't give me the R bar. Next thing you're going to go do is stat and down to edit. Stat, number one is edit. Push enter. And it gives you L1 and L2. So you're going to put X values in L1 and Y values in L2. So we're going to go into the X values. And then Y values. Okay. And then go back to stat. Arrow over to calc. And then go down to number 4, which is called linear regression. And instead of mx plus b, it's going to be ax plus b. You're going to push enter. Usually before I do this, I want to double check that my L1 and L2 are correct. So 7 and 8 are together. 6 and 7. So I'm looking at the X and Y values together. 1 and 2. 5 and 5. 2 and 1. 4 and 3. This is where a lot of the mistakes are made and it causes you to get the wrong answer. So you really got to just double check L1 and L2. Okay, now go back to stat, over to calc, down to linear regression. And just keep on pushing enter. And it's giving you the equation, but what we're looking at is for R. It's a correlation coefficient, not R squared. We only want R, okay? So what this tells us is that there is a strong positive correlation because it is 0.94. Okay, example 4. Let's go ahead and do this example where we are going to find the correlation coefficient. So I've already put it in here. Go ahead and go back to stat. Oh, the way that you clear it, let me show you that. Stat, go to edit, go up to L2, push the button that says clear, enter. Over, up to L1, press clear, push enter. And now I'll clear this out. If by accident you push delete, it'll delete these whole columns, which will make it where you have to reinsert those. And my suggestion for that is if you change these or mess these up, you need to go to clear your memory, which is second plus 712. So just be careful with that. Or go ahead and put age as your L1 and blood pressure Y as L2. Okay, now double check. We're going to go through 37, 133. 39, 143. 42, 135. 44, 151. 47, 143. 48, 158. 50, 163. 51, 146. 52, 168. 54, 160. Then I go stat, over to calc, down to linear regression. All right, so the R value is not as strong as the last one. It is 79. So you're looking at R, not R squared. So it is strong and it is positive, but it's not as strong as the last one. Okay. Here is the formula for writing the equation of regression line by hand. So it gives you how to find M, how to find B, or we can use a calculator. You're going to do the same steps. So this is the data that we just had. So they have actually given us the information here. They gave us A. Let's go just to decimal places. And then it says our equation is written like this. So that means my slope, the A value, 1.66, plus the B value, 72.93. You can actually have this data graphed on your chart, and then you can graph the line on the top. I'm going to show you that real quick. So you'll go to stat plot, which is up here. So I have to second y equals. I'm going to go to 1. I'm going to turn it on. Then I have to zoom it according to data, zoom stat. So go zoom stat. And so that's what it looks like. And then you can go to y equals and put the equation in. Go to y equals and put it in. And then hit graph. And you'll see how the line goes over the top. Pretty cool. Okay, the last part is predicting for a certain age. It says approximately what blood pressure to the nearest whole number corresponds to age 60. Use the regression line equation. So basically it's saying x equals 60. So we are going to use substitution. So y equals 1.66 times 60 plus 72.93. Gonna hit second quit to get out of there. So 172, well, if we round it, it would be 173 because it says round to the nearest whole. So the blood pressure of a 6-year-old person is approximately 173 using that linear regression model. All right, hopefully that helps you on your assignment.